Example 1. Use the trapezoid rule to find the area under the curve of y equals x times x minus 2 squared between 0 and 4 for 4 divisions. So the first thing I've done is what I've done is draw the graph, sketch the graph based on the polynomial. So I've got a 0 at 0. I've got a multiplicity of 2 at x equals 2. So I'm going to have a bounce there. So my graph is going to look somewhat like this. And I want 4 divisions of trapezoids. So I'm going to draw my trapezoids. So at x equals 1, I've got this trapezoid. At x equals 2, at x equals 3, somewhere up here, got this trapezoid. And at x equals 4, we've got another trapezoid, something like this. Okay, so I'm going to work out the y values first to fill up my table. So at x equals 0, y equals 0. At x equals 1, when I plug 1 into here, I'm going to y equals 1. At x equals 2, I'm going to get another 0. At x equals 3, I get y equals 3. And then at x equals 4, I'm going to end up with 4 times 2 4 minus 2 all squared. So that's 4 times 4. So I get 16. So then working out the areas of each trapezoid, that first trapezoid has a height of 1 and a width of 1. So it's going to have an area of 0.5. So this area here is going to be 0.5. This one is going to be the same, 0.5. Okay, so this next area is going to have an area of 1.5. Okay, through 3 plus 0 divided by 2 times the width of 1. And then this is going to be 19 divided by 2 is 9.5 times the width of 1. So I'm going to get an area of 9.5 here. So this area in here is, I'm going to write that right in there, 9.5. So the total area, summing this all up, I'm going to end up with, looks like an area of 0.5, 0.5, that's 1, 2.5 plus 9.5 is going to give me an area of 12 square units. And it looks like, it's hard to tell with my diagram, but looks like maybe it's a bit of an overestimate, it's hard to tell. So what we're going to do is compare this to the actual integral. So we can actually work out the actual integral of this because we can integrate this function. So integrating this function, we're going to compare. I'm just going to zoom in a bit here. Okay, so the actual area is going to be the area from 0 to 4 of x squared. If I expand out those brackets, I'm going to end up with x squared minus 4x plus 4. So I'm going to multiply the x in. So x cubed minus 4x squared plus 4x, and then dx. So the antiderivative works out to be x cubed over 3 minus 4, so x4 over 4. X cubed, 4x cubed over 3, plus is going to be x squared, and 4 divided by 2 gives me 2x squared, and I'm going to be integrating this from 0 to 4. Okay, so when I integrate this, I'm plugging in 4, so 4 to the power of 4 is 256 over 4 minus, and that's going to be same as 4 to the power 4, so that's 256 over 3 plus 4 squared times 2, or 32, and then minus, when I plug in 0, I get minus 0. So simplifying this becomes 64 minus 256 over 3 plus 32, so 92 minus 256 over 3, and 92 is going to be same as 288 over 3 minus 256 over 3, and that's going to give me 32 over 3 units squared, or about 10.7 So the actual area is 10.7. From the trapezoids, that's going to be 12 units squared.